focus question for today is how can I use special angle pairs to find angle measures? All right, the first type of angles that we're going to talk about is adjacent. Adjacent angles. Erase them. Adjacent angles are next to each other. Adjacent angles are next to each other. They share a vertex and a side. Adjacent angles are next to each other, share a vertex and a side. You worked with adjacent angles all last week. A picture of adjacent angles would look like this. In this picture, angle 1 and angle 2 are adjacent. They both share point A as a vertex, and they both have side B They both share side B, or in this case, AB. See it? They're next to each other. They share a vertex, and they share a side. Yes? They can be. In this case, they would be equal to each other if AB was an angle bisector. But never assume anything in here. No matter how much they look like they might be equal, unless you're told that AB is an angle bisector, or that angle 1 is congruent to angle 2, or you can find a specific definition or rule that says they're congruent, they're not congruent. Okay? So in this case, angle 1 and angle 2 are adjacent angles. If I add a third angle here, call it angle 3. Are angles 2 and 3 adjacent? Why not? Well, angles 2 and angle 3, don't they share this side?
Yeah, they're adjacent.
What? Well, it was a ray, right? And rays have an infinite number of points on them. Sometimes they're not labeled. But they shared a vertex and a side, so 2 and 3 are adjacent. Okay? What about 1 and 3? Are angles 1 and 3 adjacent? Are they next to each other? Do they share a vertex? Do they share a side? They don't share a side. Okay? So they're not adjacent. If I gave you this picture and this picture, are angles 1 and 2 adjacent? No, why not? They don't share a side or a vertex, do they? Okay? So they have to be next to each other, they have to share a side, and they have to share a vertex. All three of those have to be true for the angles to be adjacent. a linear pair of angles are adjacent and form a line. A linear pair of angles are adjacent and they form a line. So if they're adjacent, they share a vertex, they share a side, and now they form a line, right? So a linear pair would look like this. If they form a line, you have to have a line. So here is a picture of a linear pair. Angle 1 and angle 2 are a linear pair. They're next to each other. They share a vertex. It's not labeled, but it's right here. Vertex. They share a side. It's not labeled, but it's there. And they form a straight line. Hence the name linear. Linear pair. Linear means line. They form a line. The book says that their non-common sides are opposite rays. I think it's easier to remember if you just say they form a line. Okay? Share a side, share a vertex, and they form a line. Complementary angles. Complementary angles sum 90 degrees. And supplementary angles sum 180 degrees. Complementary sum 90, supplementary sum 180. Anybody have a hard time remembering that? So going back here, what else can you say about angles 1 and 2? They're supplementary, aren't they? They're a linear pair. They're adjacent. Okay? This, if you have a highlighter, this next thing is real important. So, whatever your real important color is, or your notation for real important, to find the complement of an angle subtract it from 90 degrees. To find the complement of an angle, subtract it from 90 degrees. To find the supplement of an angle, subtract it from 180 degrees. You're asked to find the complement of angle M. And then you're given a picture of angle M. And it's 26.8 degrees. Then to find the complement of angle M, you subtract it from 90. So you take 90 minus 26.8. Okay, very good. So the complement of angle M is going to be 63.2. Right? Because the two of them added together would sum 90. This is where it starts to get a little trickier if you're asked to find the supplement. Supplement of angle N. And the angle is represented by an expression, 2y plus 20. All right, this is angle N. Just stick to the rule. To find the supplement of an angle, subtract it from 180. So the supplement of N, you would take 180 and you would subtract 2y plus 20. Your supplement of N is going to be an expression because N is an expression, right? So combine like terms here. You got your 180 plus 20. So 200 minus 2y would be the supplement of angle N. So if you're asked to find the complement or supplement of an angle, you subtract that angle from either 90 or 180, depending on what they're asking. If the given angle has a numeric measure, then your answer is going to be a numeric measure, right? If the given angle has an expression as an angle measure, then your answer is going to be an expression. Okay? Yes?
When those got 160 minus 2y, so I can be subtracted 20 from 60.
You know what? You're right. You know why? Because I didn't put this in parentheses. So erase this right here. Do you guys see that negative in front of the parentheses? That's like a -1. So it's got to be distributed. So what this really becomes is 180 minus 2y minus 20, doesn't it? So now when you combine like terms, your 180 minus 20 is 160 minus 2y. 1/6, that's a 0, isn't it? 160 minus 2y. Thank you. Yes?
Is it the supplement of an angle always going to be like an expression?
No.
Okay.
No. In this case, if I were to, let's go and just focus on the blue. All right? And this was 120. And you were asked to find the supplement of angle n. Then you would do 180 minus 120, right? If instead of if now we're saying that angle n equals 120, and we're going to find the supplement of angle n, then it's just going to be 180 minus the 120, and that would be 60 degrees.
Okay.
It's much simpler to deal with when it is a number.
Okay.
When it's an expression. And that's kind of that's a huge note. That was a big mistake on my part. Okay? You got to put that expression in parentheses. And when you're subtracting it, you got to distribute that negative sign. All right? So now I want you to look at the bottom of page 29. Example 3. And let's write it down in your notes. An angle measures. Three less. An angle measures 3 less than twice its complement. Find the measure of the complement. This is example 3 on the bottom of page 29. The easiest way I've found to do this. Is everybody caught up? Is to write angle and complement. Angle and then complement of the angle. So you're dealing with one angle. You don't know what it is, right? So call it x. You're dealing with the complement of that angle. How do you find the complement of an angle? Complement. Subtract it from 90, right? So the complement of this angle is 90 minus x. Now watch, an angle measures 3 less than twice its complement. 3 less than twice its complement. So here's your angle. It's equal to 3 less than its complement. 3 less than twice its complement. So wouldn't this be twice its complement? Just putting the 2 in front of the parentheses? And wouldn't this be 3 less than twice its complement? So if you list the angle as a variable, you list the complement as 90 minus the variable. Then adjust the complement based on the problem. 3 less than twice. Okay? So now you've got an equation and you can solve for x. So x is going to be equal to, you got to distribute this 2. So you got 2 times 90 is 180 minus 2x minus 3. So combine like terms on the right hand side. So x is going to be equal to, you got your 180 minus 3 is 177 minus 2x. You can add 2x to each side. So 3x equals 177. Divide by 3. And x is equal to 59. So now look, if x is equal to 59, x was the original angle, wasn't it? But they asked you to find the complement. So wouldn't the complement be 90 minus x? So the complement would be 90 minus 59. So the complement would be 31 degrees. Look at the bottom of page 29 to check it out. And we're just going to set that one up. Okay, we're not going to work it all the way through. It says an angle's measure is 12 more than half the measure of its supplement. 12 more than half its supplement. So look, again, your setup is going to be, you got your angle, right? Which is x, and you got your supplement. What would the supplement be? 180 minus x. Right? So now it says 12 more than half the measure. 12 more than half of it. So wouldn't the 1/2 go here and plus 12? So there's your equation to solve. Anybody confused on that setup? Alright, I'm not going to finish that. I got to cover vertical angles and then I got to give you an assignment. So page 30, down on the bottom. Vertical angles. Are formed by two intersecting lines they share a vertex and are congruent. Vertical lines are formed by two intersecting lines. Vertical angles are formed by two intersecting lines. They share a vertex and are congruent. So to draw a picture of what they may look like, you need two intersecting lines. This angle right here, angle 1 and angle 2, those are vertical angles. What's another name for angle 1? Angle ABE and angle DBC are vertical angles. They both share B as a vertex. Okay, they're opposite of each other, and they're also congruent to each other. What's the other pair of vertical angles in this picture? ABD and CBE. All right. Angle ABD is congruent to angle CBE. True or false? Angle ABD is congruent to angle CBE. True or false? True. Why? Because they're vertical angles, and vertical angles are congruent. You can make it that simple. Okay. If you can identify the angles and name them, all right, then you can use that reason to prove that they're true, that they are congruent. So that would be a true. What's another name for angle 1 and angle EBC? Okay, in terms of pairs, angle 1 and angle EBC. Are they adjacent? They're supplementary, aren't they? What else are they? Are they adjacent?
Yes.
They're adjacent. What else are they?
Share a vertex.
Are they a linear pair?
Yeah.
They're a linear pair. Okay? Because they form a line. Angle 1 and angle 2. They're vertical angles. Are they adjacent? No, they don't share a side, do they? Are they a linear pair? No, they don't form a line. Okay? If I made this, just to make it simpler, this angle 3. How about angle 2 and angle 3? What are they?
Linear pair.
They're a linear pair, good. They're supplementary, good. And they're adjacent to each other. Very good. All right? So those are the kind of things you're going to have to do in your practice today. Identify certain pairs. Or you're going to have to say they're nothing. They're not adjacent. They're not a linear pair. They're not vertical angles. Okay? Questions? All right, your assignment for today